Imagine the world is made of tiny, tiny building blocks. These are called atoms. They are so small that you can't see them with your eyes, not even with a regular microscope. Everything you see, touch, and breathe is made of these atoms. Your chair, the air, your lunch, and even you are all just big collections of atoms. They are like the letters of the alphabet. By themselves, they are just single pieces. But when they join together, they can create all the amazing words and stories that make up our universe. Think of them as the ultimate Lego bricks, ready to build anything and everything imaginable. Atoms love to hang out with their friends. When atoms join together, they form a group called a molecule. Sometimes atoms of the same kind stick together. For example, the oxygen we breathe is made of two oxygen atoms holding hands. We call this molecule O2. It's like having two identical twins who are always together. Other times, different kinds of atoms team up. A great example is water. A water molecule, which we call H2O, has two hydrogen atoms and one oxygen atom. They form a super strong team that makes up our oceans, rivers, and the rain that falls from the sky. The idea of atoms has been around for a very long time, even thousands of years. But it was an English scientist named John Dalton who really brought the idea to life in the early 1800s. He imagined atoms as tiny solid balls like super small marbles. He said that each element, like gold or oxygen, had its own special kind of atom, different from all the others. He also figured out that when chemical reactions happen, atoms just rearrange themselves into new groups. They don't get destroyed or created, they just find new partners to dance with, forming new molecules and substances. So atoms are the basic units, and molecules are the structures they build. It's a simple but powerful idea. Just a few types of atoms can combine in countless ways to make millions of different molecules. This is how we get everything from simple things like salt to complex things like the DNA inside our cells. It's all about how these tiny invisible atoms decide to link up. The universe is a giant party, and atoms are the guests, constantly mixing and mingling to create the wonderful world we know. They are the true superstars of chemistry, the tiny heroes behind every substance. If you could shrink down and look inside an atom, you'd find it's mostly empty space. It's not a solid ball like Dalton first thought. In the very center of this space is a tiny, dense core called the nucleus. This is where most of the atom's weight is packed. Think of a giant sports stadium. The nucleus would be like a tiny marble sitting in the middle of the field. Everything else, the entire stadium, is the empty space where other particles zoom around. This nucleus is the heart of the atom, holding it all together with incredible force. The nucleus is home to two types of particles, protons and neutrons. Protons are the positive thinkers of the atom. They have a positive electrical charge. It was Ernest Rutherford who discovered the proton around 1919. He was shooting tiny particles at a thin sheet of gold foil and realized that something dense in the center was knocking them back. That dense center was the nucleus, full of these positive protons. Neutrons, on the other hand, are neutral. They don't have any charge at all. They are the calm peacekeepers, discovered by James Chadwick in 1932. They help hold the protons together in the nucleus. Whizzing around the nucleus, far away in that big empty space, are the electrons. Electrons are super tiny and have a negative charge. They are the opposites of the protons. It's this opposite attraction that keeps the electrons from flying away from the nucleus, kind of like how planets orbit the sun. The electron was the first subatomic particle to be discovered, found by J.J. Thomson in 1897. He was experimenting with rays in a glass tube and found they were made of tiny, negatively charged particles. He called them corpuscles, but we now know them as electrons. So, an atom has a positive nucleus made of protons and neutrons, with negative electrons flying around it. The number of protons is what makes an atom unique. For example, a hydrogen atom has one proton, while a helium atom has two. In a normal atom, the number of electrons is the same as the number of protons, so their positive and negative charges cancel each other out, making the whole atom neutral. It's a perfectly balanced little family, with the positive parents, protons, in the center and the energetic kids, electrons, running all around the house. Sometimes the nucleus of an atom is not stable. It can have too much energy or too many particles packed inside. When this happens, the atom wants to become more stable. To do this, it throws out tiny particles or bursts of energy. This process is called radioactive decay, and the stuff it throws out is called radiation. There are three main types of this radiation: alpha, beta, and gamma. They are like three different ways for an unstable atom to let off some steam. Each one is different in what it's made of and how much energy it carries. The first type is an alpha particle. Think of this as a slow, heavy cannonball. An alpha particle is actually made of 2 protons and 2 neutrons stuck together. This means it's exactly the same as the nucleus of a helium atom. Because it has 2 protons, it has a positive charge. Since it's quite big and heavy for a subatomic particle, it doesn't travel very far. It can be stopped easily by something as thin as a sheet of paper or even your skin. So while it's powerful up close, it's not very good at getting through barriers. Next up is the beta particle. This one is a bit trickier. A beta particle is a super fast high-energy electron. It's born when a neutron inside the nucleus suddenly changes into a proton and an electron. The new proton stays in the nucleus, but the electron is kicked out with great force. Because it's an electron, a beta particle has a negative charge and is much lighter than an alpha particle. It's smaller and faster, like a speedy bullet. It can travel farther and can pass through paper, but it can be stopped by a thin sheet of aluminum. Finally, we have gamma rays. Gamma rays are not particles at all. They are pure energy, like superpowered X-rays. They have no mass and no charge. They are just a wave of high-frequency energy released from the nucleus when it needs to calm down after spitting out an alpha or beta particle. Because they are just energy, gamma rays are the most penetrating of the 3. They can pass straight through paper and aluminum. To stop them, you need a very thick and dense material like a big block of lead or several feet of concrete. They are the invisible ninjas of the radiation world. For every particle that makes up our world, there is a mysterious twin called an antiparticle. This twin is almost identical. It has the same mass, but it has the opposite electrical charge. This strange stuff is called antimatter. For example, the electron has a negative charge. Its antiparticle, called a positron, is exactly the same, but has a positive charge. A proton is positive, so its twin, the antiproton, is negative. It's like looking in a mirror, where everything is the same but flipped. This idea sounds like science fiction, but it is a very real part of our universe. So, what happens when matter and antimatter meet? The result is spectacular and total destruction. When a particle touches its antiparticle twin, they both disappear in a flash of pure energy. This process is called annihilation. Imagine an electron and a positron meeting. They would instantly vanish, and in their place, a burst of high-energy gamma rays would appear. This is the most efficient energy conversion known to science, turning 100% of the mass into energy. This is what makes antimatter so powerful, but also very dangerous and difficult to handle. You might be wondering where all this antimatter is. Scientists believe that when the universe was born in the Big Bang, equal amounts of matter and antimatter were created. But for some reason we still don't fully understand, most of the antimatter disappeared, leaving behind the matter that makes up all the stars, planets, and us. Tiny amounts of antimatter are still created naturally in the universe. For example, during lightning storms or when cosmic rays hit our atmosphere. Scientists can also create small amounts of it in powerful machines called particle accelerators. Antimatter isn't just for blowing things up in theory. It has real-world uses, especially in medicine. A technique called positron emission tomography, or a PET scan, uses antimatter to see inside the human body. Doctors inject a patient with a special sugar that contains atoms that release positrons. When these positrons meet electrons in the body's cells, they annihilate and release gamma rays. A special camera detects these rays and creates a detailed map of where the sugar is being used, helping doctors spot diseases like cancer. It's a perfect example of how the universe's strangest secrets can be used to help us.